The signs of trigonometric functions. So the signs of trig functions change depending on which quadrant you're looking at. So we're going to start off by looking at our circle, okay, on the Cartesian plane. Could be better. Okay, so remember our circle on our Cartesian plane is made up of different points along the edge. And we can create rays that go through, every single point. And remember, when we were calculating our theta, we were using these rays and we were using a combination of the x and the y points to find what the trigonometric functions were equal to. Okay. So let's have a look at the points in general. Okay. So let's start off with this point in the first quadrant. So this is the first quadrant. Okay. Second, third, and fourth. Okay, so let's look at the first quadrant in the first quadrant. So we don't know anything about this circle, okay? Except that it has a radius. And we also know it's on the xy plane, okay? But we can determine individual things about these points, or the points that are on the circle. Let's just look at the points in the first quadrant. So basically, I could take any combination, not any combination, I could take any one of these points along this, between 0 degrees and 90 degrees, and I know two things about them for certain. The first thing, let's do this in blue, the first thing is that the x-ordinate will always be positive because it's in the positive part of the x-axis, okay? And the second thing I know about this is that the y value is also in the positive area because it is above the origin along the y, okay? So any point along here has a positive value for x and a positive value for y. It might seem pretty obvious, and it's going to be really helpful later on when we do our exact values. Okay. Our next one is this in the second one. Okay, so we also know two things about this. So again, picking any point along here, they all share two things in common. And that is that the x value will be negative because it is on the left-hand side of the origin, so where all the x values are negative. However, these points are still above the y-axis. Above the x-axis. So the y value, it doesn't matter what it is, but the y value in this part of the circle is always going to be positive. Now, similarly for this one here, or in the third quadrant, this point, it can be made up of any one of these. We know that it is below the x and to the left of the y. So both of these coordinates, or both the numbers of the points, are going to be negative because all the y values are below the origin and all of the x values are to the left of the origin, so in the negatives. And finally, the same thing can be said about the fourth one. The two things we know about this is that all of the x values are to the right, so they have to be positive, but all of the y values are below the x-axis, so they are negative, okay? So what we're saying is that, and let's summarize by drawing it in a table. So we've got our quadrants, okay? And our quadrants are the first, the second, the third, and the fourth, okay? And what we know about our x and our y is that in the first quadrant, they're both positive. In the second quadrant, the x is negative and the y is positive. In the third quadrant, the x is negative and the y is negative. And in the fourth quadrant, we know that the x is positive and the y is negative. Okay. We also know something about the radius. The radius, doesn't matter what the radius is. Okay, so this distance, the radius, is always a positive number. We can't have a negative radius. So our radius is always positive along there. So this is where our sign of our trigonometric ratios come in. So we remember sine theta. Okay, I'm just going to write these over here. Sine theta was equal to y over r. Cos theta was equal to x over r. And tan theta was equal to y over x. And also remembering that our cosec, sec, and cot were just the inverses of these. Now, we don't know what the numbers are, but we can determine whether sine, cosine, or tan are negative or positive based on whether or not, based on what quadrant they're sitting in, and whether the x, the y, or the r, or a combination of those will make a positive or a negative value. Okay? So remember, sine of theta is defined as y divided by r. So y in the first quadrant is a positive, r in the second quadrant is a positive. A positive divided by a positive means that if I'm doing sine of a angle that's in the first quadrant, it will give me a positive value back. And you can do that too by checking, checking any sine of any number between 0 and 90. Or, well, not including 0 and 90, but yeah. Okay, in the second quadrant, okay, we've got a positive divided by a positive again, so it's going to give me a positive answer. And you can test that too. If you put sine of 150 degrees into a calculator, it will give you a positive number in return. Now in the third one, this is where we change. We've got y is negative, but r is positive. A negative divided by a positive would give us a negative value. So if we put a negative, if we put sine of a number that's in the third quadrant, so between 180 and 270, let's put in 200, it will return a negative value. And just like in the third, we've got a negative divided by a positive in the fourth quadrant, putting sine of a number between 270 degrees and 360 degrees will also return a negative value. Similarly, let's do this for cos and tan, and we can also do it for sec, cosec, and cot. Now, cos is x divided by r. Okay, so x divided by r, well, cos is also positive in the first quadrant. So again, by checking any number between 0 and 90, you can test that. Okay, for the second quadrant, we've got a negative divided by a positive. So that gives us a negative value. So if you were to put, say, cos of 110 degrees in, you will find that your answer that you get out is actually a negative number. Continuing along, we can do our third quadrant, which is a negative x divided by a positive r. So that is also negative. And finally, we do our fourth quadrant, which is a positive divided by a positive. So our cos in our fourth quadrant is positive. So say if we put cos of 350 degrees, which is between 270 and 360, we will get a positive number in return. And we get 0.98. Okay, finally tan. So doing tan, we're going to do y divided by x. So plus divided by positive is a positive. Positive divided by a negative gives a negative. Negative divided by a negative gives a positive. Okay, so that's where this one changes. And a negative divided by a positive gives a negative. Now, you'll notice with these that in the first quadrant, all our trig ratios are positive. It just changes in the second, third, and the fourth. Okay? And there's a little rule that we can use to remember that. So if you draw a quick little sketch on the right, and we do A, S, T, C. So I showed you guys this in year 10. Okay, all stations to Central, but because we are Tamworth locals now, we decided that our little rhyme was going to be all stations to Coaldale. So all stations to Coaldale, all stations to Central, if you're more of a Sydney sider, all stations to Cardiff if you're from Newcastle where I grew up. It's just a quick way to remember in which quadrant are the trigonometric ratios positive. So the A means that all sine, cos, and tan are positive. And you can see that back over here on the left, where in the first quadrant, sine, cos, and tan were positive. This one just means that sine is. And if you have a look back at our table, along our second column, only sine is positive. Tan, cos for the last two. So T is tan, C is cos, and again, you can see that T in the third, C or cos in the fourth give our trig ratios, our positive trig ratios. So this little quick rule just is a reminder on where the trig ratios are positive. Okay, so basically it just means that, well, okay, we'll talk about this in a moment. I don't want to get too ahead of myself just yet. Okay, so now let's move on to the other ones. Okay, the new ones. Cosec and sec and cot. Okay, so remember to define cosec, sec, and cot are just the not inverses, the reciprocals of the other ones, or their partners. So r over y, r over x, and x over y. So this is where I ask you the question. If I change the fraction so it's a reciprocal, will that change the signs that I get? So by swapping the y and the r around, so it's r and y, will I be actually changing the positive, so say, you know, this positive where the sign is, to a negative, and vice versa? Well, the answer to that is no. A positive divided by a positive, it doesn't matter if you divide the first positive by the second positive, will still always give you a positive. A negative divided by a positive will still give you a negative answer, regardless of if you do the negative number first or the negative number second. So it turns out that cosec, sec, and cot actually share the same signs as their reciprocals. Okay? And that's just a really cool little thing, or a cool little sort of side thing of these ratios. But, you know, remembering that they are just the reciprocal, so they are using the same parts as cos, tan, and sine. It's just they are they're just flipped over. Okay? So with that being said, that's the end of this video. We'll be talking about how these signs and the related angles are related to each other in the next one. So I will talk to you then.